So in this video, we're going to talk about how to represent functions in a variety of ways, like multiple different representations of the same function. You might describe a function in words. You might describe it as an equation. You might describe it as a table or even as a graph. And all of these things can be used to represent the same function just in different ways. And so we're going to explore kind of the connections there. We're going to go through 4 examples. These are on the handout that I gave you that has the practice on it as well. So for this one, first of all, it wants the slope and the y-intercept of this table, and then use it to write a function. So, to find the slope, there's a couple ways you could do this. First of all, you could graph these points and count the slope. You could use the slope formula, y2 minus y1 over x2 minus x1. Or you could even just see like what is the change in y divided by the change in x. Like how much is the y going up by each time? It's going up by 3. Each time is plus 3. Sorry, minus 3. Minus 3, minus 3, minus 3. It's going down by 3 each time. And the x is going up by 1. So what is the change in y over the change in x? It's like the y goes down 3 each time the x goes up by 1. So for the change in y over the change in x, it's down 3 for each plus 1 x, which simplifies to negative 3. That's the slope. Another way to find that is just pick 2 points in the table and do the slope formula. So like, let's just use these first 2 points. Do y2 minus y1, so 1 minus 4, and x2 minus x1, negative 1 minus negative 2. 1 minus 4 is negative 3. This is negative 1 plus 2, which is 1. Which again gives me negative 3. Or I could even graph it. I've got negative 2, 4, negative 1, 1, 0, negative 2, 1, negative 5, and so on. And so you can see, you can see that this line goes down 3 over 1, down 3 over 1. So down 3 over 1. Again, a slope of negative 3. So that is my slope. I'm going to call it n. The y-intercept, you can see a couple different ways. Remember, the y-intercept is where do you hit the y-axis? You can see that on the graph I just made. It hits the y-axis right here at negative 2. That's the y-intercept. Note that when we hit the y-axis is when we have an x value of 0. Because that's where the y-axis is. So if you ever want to find it in a table, you just go see where does x give me 0, that's the y-intercept. So this right here is the y-intercept, negative 2. Because 0, negative 2 is on the y-axis. I know it's a little confusing. It's like the x is 0 and that's the y-intercept, because you've got to have a number. Okay, if I want to write a function to represent this table, that's going to be pretty simple. Because if I use slope-intercept form, I already have that stuff. I have the slope, it's negative 3. And I have the y-intercept, it's negative 2. That's it. Instead of y, you may want to use f of x. Either way, they mean the same thing. Let's try another one. All right, this one is written out in words. So rather than a function or equation, a cell phone company charges $89.99 for a new phone and then $19.99 per month. Write a function to represent this situation. So I'm going to call the function f, and I'm going to let the input be m for month. You can use f of x, that's fine too. So $89.99 is an initial fee. That's where we start. And then after the first month, you'd add another $19.99, And then after like 5 months, you'd have to multiply the 1999 times 5. Or after like 50 months, you'd multiply this amount by 50. So notice that like this amount can change. The month can change, but it always gets multiplied by that per month amount. So that tells me this is the slope. The 1999 is what I need to multiply by m, my variable, because 1999 changes based on the month. The 89.99 is by itself. It's like a one-time fee, and so it doesn't have a variable, it's a constant. It stays constant, $89.99, no matter how many months I have the phone for. That is the Y-intercept. Like even if there were 0 months, I'd still have to pay $89.99. You could use X if you really wanted to, but I just used M. All right, this time we want to write a function to represent this graph. And we've done this before. Again, to write a function, you really just need the slope and the y-intercept or the slope and a point. And it gives me that pretty much. So y equals mx plus b is the slope-intercept form. The slope here looks like it hits at -2, 1, and I'm not sure if it hits there, it's hard to see. It does hit at 0, 5 though. So I go up 1, 2, 3, 4 over 2. Oh yeah, so it must hit here. So up 4 over 2, rise 4, run 2, simplifies to 2 over 1, or just 2. So the slope is 2 over 1, and 2 over 1. So that's the slope. Fill that in for m. For the y-intercept, there it is, it's 5. So just replace this with a 5, and you've got 2x plus 5. Again, instead of y, you may put f of x. Either way, same idea. And the last one is again a just like kind of word problem scenario. Joe was given $20 for his birthday. He then saved $10 per week from his allowance. Write a function to represent this situation. I always like to think like if there were 0 weeks, like if he hadn't got his allowance at all, how much would Joe have? Well, he would have 20, because that's like his initial amount that he had. So you've got 20 no matter what. That's a constant. We're going to add to it, but that 20 doesn't change. And then you save $10 per week. So $10 depends on the week. He'll have 10 the first week, and then 20, and then 30, and then 40. So you multiply the 10 by however many weeks there are. Like if there were 5 weeks, you do 10 times 5. And there we go. You may flip the order, and that's fine. 10w plus 20. I'm going to call this function f, just to name it f, with an input of w. You don't want to call it f of x, but then use w as a variable. If you're going to use w, you've got to say f of w, because w is the input. So there we go. 10 in this case would be the slope, and 20 would be the y-intercept.